Hi students, good morning. Okay. Yesterday I have given homework this one. Okay. Let us verify. I think you are done. Check your. If you done means you can check your answer whether it is correct or not. So find the discontinuity. Find all the points of discontinuity of f of x defined by f of x equal mod x plus 3 if x less than or equal to minus 3, minus 2x if minus 3 less than x less than 3, 6x plus 2 if x greater than or equal to 3. By seeing this function, see this function changing at what point? Minus 3 and 3. Okay. F of x is changing at x equal to minus 3 and x equal to 3. In this case, we should find left limit and right limit because it is changing. So let's verify first at x equal to minus 3. Left limit LHL, limit of x tends to minus 3 minus. What is the meaning of this? X tends to minus 3. Below minus 3 comes under this. And the function limit of x tends to minus 3 mod x plus 3. Put x equal minus 3 mod minus 3 plus 3 equal to 6. Mod minus 3, 3. 3 plus 3 equal to 6. RHL, limit of x tends to minus 3 plus f of x. Minus 3 plus means above minus 3. Above minus 3. Limit of x tends to minus 3. Above minus 3 minus 2x. So x equals minus 3. 2 minus 2 minus 3 6. So left limit equal to right limit. Where here x is equal to minus 3. X is equal to minus 3. So minus 3 to minus 3, 6. Left limit, right limit equal. And next function value f of minus 3. F of minus 3 means equal. Equal minus 3, where is it? Here, not there, here. So this is, comes under this. Okay. So put x is equal to minus 3 in this. Mod minus 3 plus 3. Mod minus 3, 3 plus 3 equal to 6. Okay. So left limit equal to right limit equal to f of minus 3. Therefore, f is continuous at x equal to minus 3. Next. Second case, at x equal to 3. It is at this point also the function is changing. So we should find left limit and right limit. Limit of x tends to minus 3 plus 3 minus f of x. The meaning of 3 minus below 3. Below 3 is minus 2x. Okay. Put x is equal to 3 here. Minus 2 into 3 equal to minus 6. Left limit. Next, the right limit, limit of x tends to 3 plus f of x. Limit of above 3 comes under this. This is below 3 and minus 3 above. This is below minus 3 and this is above 3. Above 3 take the function 6x plus 2. Put x is equal to 3, 6 into 3, 18 plus 2 equal to 20. So left limit not equal to right limit. Left limit not equal to right limit. Therefore, limit does not exist. So limit x tends to 3 f of x does not exist. Therefore, f is not continuous. F is not continuous. At what point? X equal to 3. Okay, tell me the discontinuity point. 3 only. So what is the question is? Find all discontinuity point. Below minus 3, there is no changing, so it is continuous. In between, continuous. For all above 3, continuous. Okay? At what point? 3 and minus 3 only changing function. At this point, if you check it, then we can give the conclusion. At minus 3, continuous, but at 3, not continuous. Therefore, conclusion is f is discontinuous. F is discontinuous at x equal to 3. Suppose if the question is discuss the continuity if given. Discuss the continuity if given. Then how to say? Up to this, okay. After this, you have to discuss below minus 3. Below minus 3, mod x plus 3 is always continuous because mod x is continuous plus 3 constant continuous. Above minus 3 to plus 3 between minus 2x which is polynomial. Therefore, it is continuous. And above 3, 6x plus 2 which is also polynomial. Then it is continuous. If the question is discuss the continuity, if they ask like this, you should discuss each and every point. Okay? Just if the question is only find all the points of discontinuity. So discontinuity means at what point changing, there only you can find. Other points you need to find. Okay? Copy this one. Now the next question is exercise 5.1, question number 8. Find all the points of discontinuity. Find all points of discontinuity of f where f is defined f of x equal mod x by x when x not equal to 0. 0 if x equal to 0. See, at what point it changing by seeing the function? 0. Actually, x not equal to 0, but mod x is there here. So mod x is changing at what point? 0. The mod x, the definition of mod x is x when x is greater than 0. Minus x when x is less than 0. So the mod x is changing at what point? 0. Here mod is there, so it's changing at 0. So we should find, while finding the limit at 0, we should find left limit and right limit. Okay? Now we are going to find f of x changing. F of x changing. At what point x equal to 0? Find left limit, LHL, limit of x tends to 0 minus f of x. Right? Limit of x tends to 0 minus means x not equal to 0. X not equal to 0 function is mod x by x. Again, one more is there, below 0. Below 0. When x is below 0, if x is less than 0, then mod x equal minus x. Change the function here. Limit x tends to 0, mod x minus x by x. Get cancelled, which is equal to minus 1. So left limit equal to minus 1. Left limit equal to minus 1. Understood step? Here x tends to 0 minus, but below 0 not given here. But what they given? Not equal to 0. X tends to 0 minus means x not equal to 0 and below 0. So first you take x not equal to 0 function. Then again one more inside function is there, mod x. Mod x means below 0. If it is below 0, the mod x equal to minus x. So get cancelled, minus 1, left limit. Next, right limit. Limit of x tends to 0 plus. X tends to 0 plus means x not equal to 0 and above 0. First you take not equal to 0 function. F of x. So limit of x tends to 0 plus mod x by x. As x tends to 0 plus, the mod x equal to x above 0. x by x. Here plus cancel. X get cancelled, so equal to 1. So left limit equal to right limit. Therefore, limit exists. Not equal, left limit not equal to right limit. Therefore, limit does not exist. F of x does not exist. Therefore, f is discontinuous. F is discontinuous at x equal to 0. F is discontinuous at x equal to 0. Copy. Next, question number 9 is homework. Question number 9, homework. Next, question number 10, 11, 12 are all same. Now I am going to discuss question number 12. Question number 12. F of x equal to x power 10 minus 1, comma, if x less than or equal to 1, x square if x is greater than 1. Find all points of discontinuity of f defined by them. Okay? Tell me, by seeing this function, f of x is changing at what point? 1. F of x is changing at what point? F of x changing at x equal to 1. So let's verify the continuity at x equal to 1. If it is continuous at 1, then entire function is continuous. Okay? If it is not continuous at 1, then f is continuous everywhere but not 1. That is. So the changing function is very important. At what point changing, there you should first find. Then we come to know that. Okay? At that point only whether it is continuous, then entire function is continuous. If it is discontinuous, except that point, the function is continuous. Right? Left limit LHL. Limit at what point we are going to find? 1 minus f of x. Below 1, limit of x is to below 1. Below 1. X raised to 10 minus 1. Put x equal 1 here. 1 power 10 is 1 minus 1 equal to 0. RHL. Limit of x tends to 1 plus f of x. Limit of x tends to 1 plus above 1 x square. Put x equal 1 here. 1 square equal to 1. So left limit not equal to right limit. Then no need to find function value. If it is equal, then go for function value. Okay, left limit equal to right limit equal to function value, then it is continuous at that point. Okay, here limit not equal to right limit means limit does not exist. Therefore, f is discontinuous at what point? F is discontinuous at x equal to 1. Okay, for example, if the question is given, discuss the continuity of f of x function defined by like this. Discuss the continuity means say f is discontinuous at x equal to 1. Next we have discussed below 1 and above 1. Tell me below 1. If x less than 1, case first. If x less than 1, f of x equal to x power 10 minus 1, which is polynomial. Therefore, we know that every polynomial function is continuous. Therefore, f is continuous if x less than 1. Next, case 2. Tell me the case 2 is if x greater than 1, f of x equal to x square. Then f is x square is polynomial. Then every polynomial function is continuous. Therefore, f is continuous everywhere except 1. That is. Only if the question, as per the question, you can solve it. If they ask find the all discontinuous point means just you find a turning point, changing function, changing point. Okay? No need to verify non-changing point. But discuss the continuity means you should discuss for all each and every point in the domain of f. Below 1, above 1 and at 1. There is a difference. Discuss the continuity and find all the points of discontinuity. Homework question number 9, 10, 11. One more question. Question number 13. Is the function defined by f of x equals x plus 5 if x less than or equal to 1, x minus 5 if x is greater than 1, a continuous function. A continuous function. See, tell me what to do first step. First, let's verify at what point it is changing. At what point changing is 1. So f is changing at x equal to 1. Now I am going to see below 1. Is it continuous? Below 1. If x is less than 1, it's continuous? Yes. Why? Because polynomial. No changing. Above 1, polynomial, therefore continuous. At 1, you have to verify. At 1, you have to verify. We should find left limit and right limit. Okay? Below 1, polynomial. Above 1, polynomial. So continuous below 1 and above 1. But at 1, you have to verify. Okay? Now tell me LHL. Limit of x tends to 1 minus f of x. Limit of x tends to below 1, x plus 5. Put x equal 1, 1 plus 5 equal to 6. Right limit of x tends to 1 plus f of x. Limit of x tends to above 1, x minus 5. Put x equal 1, 1 minus 5 equal to minus 4. So LHL not equal to RHL. Therefore, limit x tends to 1, f of x does not exist. Therefore, f is discontinuous. F is discontinuous at x equal to 1. So, what is the question? Is the function defined by is a continuous function? No, it's not a continuous function. Why? Because it is a discontinuous at what point? 1. So therefore f is not continuous function. Okay? F is continuous at what point? All real number except 1. F is continuous less than 1, above 1 but not 1. The meaning is all real number less than 1, above 1 means all real number except 1. So f is continuous at all real number except 1. Next, the question number 14. Discuss the continuity. Discuss the continuity of the function f. Where f is defined by f of x equals 3 if 0 less than or equal to x less than or equal to 1. 4 if 1 less than x less than 3. 5 if 3 less than or equal x less than or equal to 10. See the difference between this 14th question and 12th question. What is the difference? There the question is find the discontinuity points. Find all the discontinuity points. Here discuss the continuity means we have to discuss each and every point. Not only changing function, not changing point. Each and every way in the domain of this. What is the domain of f of x? 0 to 10. Close interval 0 to 10. This is the domain of f. In this domain, we have to discuss each and every point about the continuous. Okay? Tell me, first it is changing at what point? Tell me. F is changing at x is equal to 1, 3, this much only. Not 10, not 0. Why? Because above 0 not given and below above 0 given but below 0 not given. Changing means right and left. It should be different. So here below 1 is 3, above 1 is 4. Below 3 is 4, above 3 is 5. So at these 2 points it is changing, but not 10, but not 0. Because above 10 not given, here below 0 not given in the domain. So don't consider at 0, 10 the function is not changing. Yes, f is changing at x equal to 1 and 3. Let's find at x is equal to 1. Let's find the continuity at x equal to 1. Let's verify. LHL limit x tends to 1 minus below 1. Tell me below 1 is 3. RHL limit of x tends to 1 plus f of x above 1 4. See, left limit not equal to right limit. Therefore, limit x tends to 1 f of x does not exist. Does not exist. Therefore, f is discontinuous. F is discontinuous at x is equal to 1. Next, at x equal to 3, left limit LHL limit of x tends to 3 minus f of x, limit of below 3 4. RHL limit of x tends to 3 plus f of x above 3 5. So here also left limit not equal to right limit. Therefore f is discontinuous at what point? F is discontinuous at x is equal to 3. Okay, we have discussed at changing point. Now we are discussed above 0 to 1. If x lies between 0 less than or equal x less than 1, because at x, don't take equal 1. The equal 1 we already have checked it. Equal 1, f is discontinuous. If 0 less than x less than 1, then f of x equal to, tell me, 3, which is constant polynomial, which is polynomial, constant polynomial, which is constant polynomial. Okay, every polynomial function is continuous. Therefore, f is continuous. F is continuous at x less than 1. 0 less than or equal x less than 1. F is continuous. Case 2. Next case. Second case is 1 to 3 between. Okay. If x lies between 1 to 3, tell me, then f of x equal to 4. Say, which is polynomial, therefore it is continuous. F is continuous. F is continuous at 1 less than x less than 3. Third case is if 3 less than x less than or equal to 10, then f of x is equal to 5, which is also continuous. Polynomial, stop, 2 minutes. Which is f of x is equal to 5, then f is continuous. F is continuous. H 3 less than x less than or equal to 10. So what is the conclusion here? F is continuous. F is continuous. Tell me the conclusion. F is continuous at x belongs to all real number except 1 and 3. Except 1 and 3. One more. Okay. Dear students, today I am giving homework. The question number, page number 159. Page number 159. Question number 9, 10, 11 and 50, 60. These questions are, you try yourself. Any doubt, you can call me and ask your doubts through WhatsApp or my personal number.